So it is quite an interesting question. It is the same question that you would expect if you have replaced the charges with the masses, right? Because gravitational field and electric field, we have the same underlying concepts, right? So the figure above shows two positively charged particles, the plus q charge in fixed in position and plus small plus q charge is brought closer to plus q and released from rest. Which of the following graphs best depict the acceleration of plus q charge? Right. So the acceleration equation for an electric field or in an electric field is given by k q1 k2 over r squared, where r squared being the distance from the center of the charges. This k is given by 1 over 4 pi epsilon naught, but we do not need the values of k or whatsoever in this question, right? So what are the constants we have? We have this as a constant, this as a constant, this as a constant. So all of those are not going to change. So what is going to change as we move one charge or that charge from one place to another is this r. So we are going to keep this in the y-axis and we are going to keep this in the x-axis. So it is a 1 over x squared graph. So you remember the 1 over x squared graph is given by this, right? So if you're going for minus as well, it will look like this, right? But since none of the graphs have negative value, we don't need to worry about that. So this is kind of this variation, right? So my question is, what is going to happen when r is equal to 0? So in mathematical way, we won't say r is equal to 0, rather we will say as r approaches 0. So as r approaches 0, we know that acceleration of the electric field or due to the electric field between the charges will approach infinity. It is not going to go to a particular value, right? So this is going to a particular value, this is a particular value, this is a particular value, this is also a particular value. And here also a particular value, which is quite interesting. Well, in that case, we should understand that none of the answers are right? But just for the sake of this question, I'm not going into that depth, right? So we can't have a straight line, right? We are not going to have an increasing or this type of a variation because I have shown you this one. And this is quite weird. It doesn't happen. The value that you have is this, right? So that is your only possible value as of now. But this is quite a wrong graph because when r is equal to 0, there is an acceleration, which is not possible, right? Because according to the math, we know this. So let's say when this graph could be a possible, or for what scenario this graph could be a possible graph. If we go to the gravitational field, right, for a change. So let's say these are two masses. One of the mass is having capital M, the radius is r. I am bringing this small m, and let's say this is capital R, okay? And I am measuring the distance to the simple m, or the mass that I am bringing closer to the bigger mass, from the surface of the bigger mass, and I am going to call that as R. In that case, this graph is going to be a possible graph. The reason is the acceleration due to gravity is also given by a very similar equation. So here we are not going to have that. My bad. I don't know why, but so if it is a force, then that Q2 would be there. Otherwise, that Q2 will not be there. So it is Gm over R squared. But we know that we are measuring this R from the surface of the mass, right? Or the planet or whatever. In that case, on the surface, we are going to have an acceleration due to gravity because we have a distance from the center of the mass there, right? So what is the acceleration due to gravity on the surface? It is given by Gm, and the distance from the center to that point is R squared. So when simple r goes to infinity, or when simple r is exactly equal to 0, right? Here we can have exactly equal to 0. In the previous case, we cannot have exactly equal to 0, right? Understand the differences. When simple r is exactly equal to 0, the acceleration due to gravity is given by Gm over capital R squared, where capital R is the radius of the planet. So in this case, we can have a graph that is intersecting the y-axis, and the intersection point is GM, okay, capital GM over capital R square. So that is the intersection point. All right. Any questions? Cool.